In this video, I'm going to cover how to deal with powers and fractions. So whenever you have a fraction, for example 3 over 7 raised to some power, let's say 2, how do we deal with stuff like this? Well, let's start off with a generic expression. So let's say we have a fraction a over b, okay, and a represents any number or any integer which is positive, okay. So if you have a over b raised to some power n, okay. So what this means is, so n is the exponent or the power, okay. Exponent and power are synonyms, and a and b are integers, okay, integers, but they're positive, okay. We're gonna look at the case when they're negative in a second here, but for now let's consider that they're positive. So the answer to the problem when you have a fraction which is written in the form of a over b to the power of n is as follows. So you have a fraction a over b over n. The answer is going to be a over b times however many times, or by however much n is, okay. So for example, if n is 1, your answer is just going to be a over b, okay. However, if n is 2, your answer is going to be a over b times a over b, okay. So a over b, if for example n is 2, your answer is going to be a over b times a over b. So you basically multiply a over b by itself by whatever n is, okay. So since n is 2 here, we multiply a over b multiplied by itself 2 times, okay. And if n was 3, a over b would be multiplied by itself 3 times, right? We would have another a over b here if n was 3, okay. So let me give you an example. So let's say you have 2 over 3 to the power of 3, okay. So over here, going back to our formula, a over b, well in our case, in this case, a is 2 and b is 3, right? It's written in the same form. And our n, what's our n? N is 3, okay. So the answer to this problem would be, well, you just write a over b however many times n, basically. So since n is 3 in this case, we just write a over b, which is 2 over 3, 3 times. So our answer to 2 over 3 to the power of 3 is just 2 over 3 times 2 over 3 times 2 over 3, right? Whatever that gives us, okay? And that would give us exactly, well, 2 times 2 is 4, times 2 is 8, so that'll be 8, and then 3 times 3 is 9, times 3 is 27, okay? So basically, this formula, it always works as long as a and b are integers, but they have to be positive, and n is an exponent or power, okay? Any exponent or power. So let's look at another case. So we have a over b, right, to the power of n. A over b to the power of n can be, it's the same thing as a to the power of n divided by b to the power of n, okay, where again a and b are positive integers and n is an exponent or power, okay. So let's look at an example for this one. So let's say we had 2 over 3 again to the power of 3 again, right, as in our last example. So what I'm telling you is, well, we can write a over b to the power of n like this, a to the power of n divided by b to the power of n. Well, what that means is we can write this as 2 to the power of n, our n is 3, divided by b to the power of n. Our b is 3 here. To the power of n, our n is 3. Okay, and when we simplify this, what do we get? Well, 2 to the power of 3 is, well, 2 times 2 times 2, which is, right, here, let me just do it here. 2 to the power of 3 is 2 times 2 times 2, divided by 3 to the power of 3 is 3 times 3 times 3. And that gives us, well, 2 times 2 is 4, times 2 is 8, so 8. And then 3 times 3 is 9, times 3 is 27. So that gives us 8 over 27. And what you may notice here is we get the same answer as above. We got 8 over 27 here, right? And that makes sense because what I'm saying is whenever you have a fraction such as this, you can get the answer by writing it out 3 times and doing the multiplication, or you can just do it this way. They're both the same. They both work, right? Because over here we have 8 over b to the power of n, and I'm saying that that's equal to a to the power of n divided by b to the power of n, right? And when we do it, we in fact get the same answer. We get 8 over 27. Okay. So let's look at another example. So let's say we have, how about if we have a negative up front? So we have a negative, and then we have a over b to the power of n. What would this give us? Well, the answer would actually be the same as when we had a over b to the power of n with no negative, but then we just stick a negative up at the front. Okay, so what do I mean by that? Well, let's say we had 2 over 3, right, to the power of 3. But then in this case, we have a negative at the front. So we have a negative at the front. Well, we do our problem ignoring the negative, basically. Because we can just do 2 over 3 to the power of 3, which we found in our previous example was 8 over 27, right? Which was 8 over 27, right? And then since we have a negative, we just put a negative in the front. So our answer now is just negative 8 over 27. So whenever you have a negative in the front of a fraction like this, well, you just compute this part first. So 2 over 3 to the power of 3, and we get 8 over 27, and then you just add the negative. Okay, so let's see another example just to clarify that. So let's say we had 1 over 4 to the power of 2, but then it was negative. How would you do this problem? Well, you would just do 1 over 4, right, times 1 over 4, which is, well, 1 times 1 is 1, and then 4 times 4 is 16. So 1 over 4 times 1 over 4 is 1 over 16. But then we have the negative up front. Well, we just add the negative up front here. So then we get, as our answer, negative 1 over 16. Okay. Okay, so let's look at another case. Let's say we have a negative a inside over b to the power of n. Okay, so this is different than our last case, because in our last case, remember, we had a negative outside the bracket. Now it's inside. Okay, so negative a over b to the power of n is just, well, whatever n is, we just write negative a over b that many times, right? So if n was 2, for example, it would be negative a over b multiplied by negative a over b, right? But we have to remember that the negative is inside the bracket, okay? And we have to keep the negative when we do the multiplication, okay? So for example, let's look at if we had negative 2 over 3 to the power of 3. Well, this would give us negative 2 over 3 times negative 2 over 3 times negative 2 over 3. Okay, and when we do that, we get negative 2 times negative 2 is 4, because it's a negative multiplied by negative, so that gives us 4. And then positive 4 multiplied by negative 2 is a negative 8. Okay, and then 3 times 3 is 9, times 3 is 27. So the answer is negative 8 over 27. Okay? So the thing here to remember is when the negative is inside, we have to keep that in the multiplication. Okay? Over here, the negative was not on the inside. Okay? So we did the 2 over 3 to the power of 3, but then we added the negative later. Okay? So a final rule that I want to discuss when dealing with fractions and powers is a simple trick that you can use to check your answer. So we had our general formula, a over b over n, or to the power of n, sorry. A over b to the power of n. So if a over b is less than 0, then the answer will be positive. Okay. If n is an even number, so if n is even. Okay. So let me go through that again. So if a over b, so if this number in here is less than 0, okay, so it's a negative number, in other words. So less than 0 means a negative number. So if this is a negative number, then the answer to this problem will be positive if n is even, but it will be negative, if n is odd, Okay. So again, if this number is a negative number, then the answer to this problem will be positive if n is even. So if this is an even number, so let's say this is a negative number and this is an even number. What will our answer be? Will it be positive or negative? So if this is negative and this is even, well, the answer will be positive, right? Because n is even. Okay. If this was odd, for example, the answer would just be negative. Okay. So let's look at our problem that we just did here. A over b. Our a over b is negative, right? If a over b is less than 0, which means it's a negative, so it's a negative in this case. And look at our n. It's an odd number, right? So what do we get when we have an odd exponent here? Well, let's look down here in our rules. If our exponent is odd, we get a negative number, right? And that's exactly what we get here. We got a negative number. Okay, so let's do an example just to clarify this concept. So let's say we have negative 2 over 3 to the power of 2. What does this give us? Well, it's going to be negative 2 over 3 times negative 2 over 3, right? And that gives us, well, negative 2 times negative 2 is positive 4, and then 3 times 3 is 9. So our answer is 4 over 9. Does that agree to the rules? Well, a over b is negative, and our exponent is an even number. When our exponent is an even number, we should get a positive answer, and that's exactly what we get, right? If a over b is less than 0, then the answer will be positive. The answer will be positive if n is even, and n is even here, right? And we get a positive answer. So that's correct. So let's change that into an odd. Let's change n now into an odd number and see if we get a negative number, because we should, right? According to these rules. So let's say we have negative 2 over 3 to the power of 3. What does this give us? Well, it gives us negative 2 over 3 times negative 2 over 3 times negative 2 over 3. And that gives us, well, negative 2 times negative 2 is 4, positive 4. And then that multiplied by negative 2 is negative 8. Okay, and then the denominators, we get 3 times 3 is 9, times 3 is 27. So our answer is negative 8 over 27. So our answer is negative, right? And that makes sense because according to our rules, if a over b is negative, which it is in this case, negative 2 over 3 is a negative number, then the answer will be negative, right? The answer will be negative if n is odd. Our n is our exponent. And in our case, n is odd, right? 3 is an odd number. Okay, so if a over b is negative and our exponent is odd, we should be expecting a negative number, and that's exactly what we get here.